Hello and good day. In geometry, we're covering CO6, kind of our lesson on angles, our introduction to angles. And we start with a few definitions like we usually do here. Angle bisector. Any thoughts as to what an angle bisector might be? Ooh, a couple hands in the air. Okay. Oftentimes in geometry, you can kind of take apart the word and figure out what it's referring to. Sebastian, what do you think angle bisector means?
Like if you have a 90-degree angle, the bisector would be like 45 degrees, just in the middle of that angle.
Okay, so what Sebastian's saying is that if you have a right angle here, the bisector would be coming out from the vertex. Whoops. This is where my pen calibration is really going to hurt me here, but I'll try it again. Coming out of the vertex. Okay, and it's going to divide that angle in half, right? And he's exactly right. The word bisector, okay, bi meaning two, sector meaning sections, two sections, all right? And the caveat to that is that the two sections will be equal, right? So an angle bisector is a segment, ray, or line. Remember, that's kind of my abbreviation for segment, ray, line. Could be anything, but a segment, ray, or line coming from the vertex what? Segment, ray, line. It could be a segment, could be a ray, could be a line, but rather than writing all the words out, SRL. Coming from the vertex that divides the angle into two congruent parts. Okay? I can write congruent better than that. Two congruent parts. A segment, ray, line coming from the vertex that divides the angle into two congruent parts. Okay? How about a linear pair? Linear pair. Yeah.
Pair of lines?
Close. You're getting there. I mean, I like you said line, right? Linear, we see the word line in there, and pair, I can see where you'd make that pair of lines. Not quite, Elise. Not two segments that make a line. Sorry? No. What's the point of the overall topic of the page today? Angles. Okay. Two angles that make a line. Okay, two angles that make a line. Now you might be asking yourself, how can angles make a line? Well, what we're talking about here is if you have, angle 1 and angle 2. Man, this calibration is just throwing me. I know how to reset it, and I did, but it's just not quite. Okay, so we have angle 1 and angle 2, right? Angle 1 is clearly obtuse, angle 2 is clearly acute, and together they make a line. And because they make a line, and we know they do because we got the arrows on each end here, what do we know about angles 1 and angle 2? Particularly, if I ask you for the measure of angle 1 plus the measure of angle 2, what do they have to equal? Because they make a line. 180 degrees. Okay? So the thing to know about a linear pair is that, first of all, it's only two angles. Okay? Not 3, not 4, but only 2. And their sum has to be 180 degrees. Because if they make a line, that's the measure of a line. It's a straight angle. Vertical angles. Any guesses as to vertical angles? Yeah.
Two angles that line up next to each other?
Next to would actually be adjacent angles.
Oh.
Okay. Elise?
Two angles that are opposite each other?
Yes. Vertical angles are two angles opposite each other when two segments, rays, or lines intersect. Two angles opposite each other when two segments, rays, lines intersect. And similar to how linear pair angles have a relationship, their sum is 180. What's the relationship between two vertical angles? Here's an example of what they look like. Okay, angle 1 and angle 2 would be vertical angles. What's their relationship? What's their relationship? See, it's some new voices today. Someone we haven't heard from yet, maybe. Brave souls. All right, Gabby. Yes, vertical angles, which I'll abbreviate VA. Vertical angles are congruent. Okay, so angle 1 is congruent to angle 2. A second pair of vertical angles would be 3 and 4, right? They're angles opposite each other when two, in this case, segments intersect, and they are congruent. Does everybody know what the congruency symbol for angles is? For segments, remember it's that little tick mark? Okay? Anyone know what it is for angles, the congruency?
Like, kind of like if it's a right angle, it'd be like a.
Well, that's just showing you it's a right angle. If it's a right angle, see that little box in the corner? That just tells you it's a right angle.
The number of lines or the. I don't know how to describe it.
Okay, you might be onto something.
Like the angle sign and the letter of the angle, and then.
Yeah, we could use the congruence like here. If we want to say angle A is congruent to angle B, we could write it as a statement like that. Or you could use arcs. Okay? Those arcs would represent that 1 and 4 are congruent. Or 1 and 2, sorry. Okay? The angle addition postulate. If you remember what the segment addition postulate was, the angle addition postulate is pretty much the same thing, only about angles. So what is it? Flip back to CO2 if you need to look at the segment addition postulate. Noah? Right. The angle addition postulate says that the parts of an angle will sum to equal the measure of the whole angle. And the parts of an angle will sum to equal the measure of the whole angle. So, for example, okay, if we had if I told you that the measure of angle ABC equals 80 degrees, what's the measure of angle 1? Boys? If the measure of angle ABC is 80 degrees, what's the measure of angle 1? Which angle 1 is this top part of that whole angle. Your agent's trying to get a hold of you too. Okay. Yes? Oh, yes. 50. Okay, because 50 plus 30 equals 80. Right? So a similar thing that we saw with the segment addition postulate. All right. Questions on any of this so far? Okay. Coming down here then, I believe we go back to a little bit of algebra. Of course you do. And so we have Find the requested angle measure. Check your answer by verifying that the relationships work. I'm looking for the measure of angle ABC and the measure of angle CBE. Okay? So ABC, underline that in green, that's this one right here. I want to know what that is. And then the measure of angle CBE, right here, going from C to point B and down there, I'm looking for that angle there. So look at this picture here and tell me what relationships you see. What is an equation that we could set up that would allow us to find the measures of angles ABC and CBE? Look for those relationships. What do you see? Erica?
It looks like ABC and EBD are the same.
It looks like ABC and EBD are the same. So Erica's saying it looks like ABC is congruent to angle EBD. Who can either back her up or correct her? Because when you say it looks like, it makes you nervous, right? But is she right, and why? Elise?
She's right because
They're vertical angles. Okay? We've got two segments here, and we know that because they've got the endpoints, right? DC, segment DC, which we know has got to be straight, intersects segment AE at that point. When that happens, the angles that are opposite each other, which in this case ABC and EBD, have to be congruent, right? So we know that the measure of ABC is 2x plus 7, and we know that has to be equal to the measure of EBD, which is 4x minus 14. And similar to when in CO2, when we had those segments, we have an algebra equation, in this case variables on both sides, to solve. Okay? What did you end up with for a value for x? Brady, do you have something else? Or? Oh. I mean 4x minus 14 equals, yes. If you have 4x minus 14 equals 2x plus 7, that's okay. Yep. What'd you get? Yeah. 10.5?
Yeah.
Okay. Okay. So if x is 10.5, that's not the answer. The answer to the question being asked. The question being asked is, what is the measure of angle ABC? If x is 10.5 and ABC is 2x plus 7, what do we get? Evan? 28 degrees. Okay. Plug in 10.5 for x. 2 times 10.5 is 21. 21 plus 7 is 28. Now we might be in a bit of a pickle, right? Because we're asked to find the measure of CBE, which is this angle I've outlined kind of in red here, but there's no value given to us. Thumper. Why? And thus they make a linear pair, right? ABC and CBE make a linear pair because together ABC and CBE make this line, right? So if ABC is 28, Thumper says we can subtract 28 from 180, and it's going to give us the measure of CBE, and he's absolutely right. Okay? So we get a value of 152, right? Again, we see that kind of puzzle piece thing here. We see those relationships. The quicker you are able to identify those, vertical angles, linear pairs, etc., the more efficient and the easier this is going to be. Okay? The second one, which I'm going to leave for you to do for homework here, I want you to find angles POR and ROQ. Okay? Now, in this case, we got three angles here. Are these three angles, do they make a linear pair? They don't, because they're three angles instead of two. However, is there some still 180? Yes. The three angles do make a line. So even though we can't call them a linear pair, because a linear pair is reserved for only two angles, because they make a line, their sum is still 180. So there's a relationship you can use right off the bat that'll help you solve for x. In addition to this page, in addition to the one homework question that I assigned you, in your textbook on page 29, so fill this in at the bottom of your binder page so you know what to do in addition. And you have till Thursday, so calm yourselves. 22 through 26, comma. I'm not done. 29 through 30. Whoops, I lost my mic. Sorry for that thud. And 29 through 38.